Okay, so students, now I'll show you the fourth experiment of Advanced Physics 1 lab. So this experiment is called polarization by wave plates. So first I will show you what are the basic components which will be required for this experiment. So first I'll show you about this. So it's actually called optical rail. So this kind of arrangement, this kind of platform is required whenever the longitudinal arrangement is extremely necessary. And you can see there are various mounts which are attached to the optical rail, and it can rotate it, it can displaced along this direction, and you can actually quantify their position also in terms of the scales. Okay, so other than this, the rest of the things are similar. Like here we will be using this direct laser. This power is 5 milliwatt typically, and it is emitting red wavelength. And once again, this is the silicon photodetector, and attached to that there is a current meter. You can see the current, so it's 17.2 milliampere. Okay, now as the name suggests, we will try to polarize the light. Okay, and the way we will do is the following. If you can see that, then this is called a polaroid or a polarizer. It's actually sheet polarizer. So it's made of polymer, which is embedded within a glass substrate. It actually polarizes the light. If you can change the angular position of this, the state of polarization will rotate. Okay. So what I'll do is I'll just fix this one in front of the laser, and I'll try to convince you that it actually polarizes the light. So you can see the output light, and for the time being just assume that it is polarized. Now it's very difficult to get convinced because just by seeing you can't figure it out, right? But the way I'll try to convince you is the following. Suppose this is the first polarizer and its path axis is along this direction. Now if I keep another polarizer whose path axis is perpendicular to the earlier one, then if the light is falling from this side, then no light will go out from this polarizer, right? So it will be completely blocked. So I'll do the similar thing over here. Now you can see that this power is coming. Okay, and now I will keep this polarizer, second polarizer over here, and now what I will do is that I will keep on rotating the position of the second polarizer, and now you will see that for a particular position of the second polarizer, I will not be able to see any light over there. Okay, the photocurrent will be very feeble. Okay, so now I will change the scale. It will be microampere now, and so it's 0.2 microampere. Okay? It's very minimal. You can see any light which is coming out from this. Okay. Alright, so now the path axis of the first polarizer and the path axis of the second polarizer are normal to each other, perpendicular to each other. Okay. Now what I will show you, I will use this piece of component. It is called quarter wave plate. Okay. This is actually made of quartz glass, which is a birefringent crystal, and I will keep this quarter wave plate over here. The role of this quarter wave plate is that it will actually change the state of polarization of the incident light. If the linear polarized light is passing through this quarter wave plate, it will become elliptically polarized light, and on certain case it will give you circularly polarized light. Okay, so how will I show it to you? I will keep the quarter wave plate in certain orientation, and then now I will change the second polarizer. Now if the state of polarization is equal to the ellipse, if it is an elliptical polarized light, then the minimum value will not be equal to 0.2 microampere. It will be larger than this. Okay, so I will rotate the second polarizer. You can keep an eye on this current meter and you will see that what would be the minimum value. You can see its value is roughly around 6.5 or 6.6 milliampere. However, having said that, there will be two such orientation of the quarter wave plate where the output of this light will be plane polarized once again. You can give it a thought. Okay. Okay. Now what I will show you is that the working principle of a half wave plate. It's also similar to the earlier one, but its working principle is different, and the output of the light which is passing through this will also be different. The half wave plate will actually change the orientation of the linearly polarized light. So when the light is passing through the half wave plate, it will once again be linearly polarized, but the orientation of the polarization will change according to the rotation of the path axis of this half wave plate. So the linearly polarized light is coming from this first polarizer. It is passing through the half wave plate. Its state of polarization will change. It will be along any arbitrary direction based upon the position of this. And now what I will show you, now since the output of this half wave plate is once again linearly polarized light, so now if we rotate the second polarizer, there will be a position where you will get very minimal photocurrent. You may not get the exact 0.2 microampere, but the value will be substantially low. I will show you. I will change the scale now. Okay. You can see the value which you are getting is roughly 20 microampere, which is substantially lower than the earlier one. So this is all. So I actually have shown you that how by using the quarter wave plane and the half wave plate you can change the state of the polarization of the light. So that's it. Thank you.